So hello everyone. In this video we are going to see the solution of this problem, that is palindrome linked list. So in order to solve this problem we are going to use functional programming. Okay, so just fancy terms. Okay, so functional programming. So in simple words we are going to create some functions in order to solve this problem. Okay, so we need to check that whether our linked list is a palindrome. Okay, so we are going to take help of is palindrome function. Okay, just random name. Okay, so what it will do is it will check that whether our linked list is a palindrome or not. And now let's see that what approach we are going to use and what other functions we require in order to solve this thing. So what we are going to do is, suppose we are provided with a linked list. Okay, this is our linked list, suppose 5, and we need to find out that whether this is a palindrome or not. So what we are going to what approach we are going to use here is that we will first find out the midpoint of our linked list. Okay, so in order to find the midpoint of the linked list we will require a midpoint function. Okay, midpoint function. Now what we are going to do, we will see that this, suppose this will be our second half. This will be our first part. After the midpoint we have a second half of our linked list, and before that we have the first half of our linked list. So this second half of our linked list will be, so like we can write it like list node, and we can name it as second half. So it will be nothing but midpoint dot next. Okay, so we will write something like that, midpoint dot next. Okay, so this will start pointing towards this 4. Okay, now we will break this link, so this will be our second half. Okay, now in order to check that whether these both the first half or second half is equal or not, so what we need is we need to reverse this linked list, the second half. So in order to reverse this linked list we require another function, that is reversal of a linked list, or reverse function we need to require. Okay, reverse function. After reversing our linked list, our linked list will become, so here uh, like the flow is like that, so it will become something like that: 1 2 3 and 4. Now till the time our second half is not equal to null, what we are going to do, we are going to check that whether the value of the the first half dot val is equal to the second half. Then we will proceed. We will you know will move next to the next node. We will use first half dot next and then second half dot next if both are true, and if not, if the values are not equal, what we are going to do, we are going to return false as our answer. So this is the whole logic that we are going to use in order to solve this problem. Now let's think about, so we have understood that what we are going to do in the is palindrome function. Now we are going to talk about the midpoint function and as well as the reverse function we are going to see. Okay, so quickly we will move down. So midpoint, how we are going to find. Okay, so in order to find the midpoint of a linked list, now we use this approach, that is fast and slow pointers. Okay, so suppose our our slow pointer is pointing towards the head, and so is our fast pointer. So every time our slow pointer moves one node ahead, our fast pointer will move 2 nodes ahead. Or in simple words, the speed of the fast pointer is twice that of our slow pointer. So suppose if it moves one node ahead, so fast pointer will move 2 nodes ahead. Okay, and if it again moves one step ahead, it will move 2 steps ahead. So till you know fast dot next is not equal to null and fast dot next, okay, dot next because it is moving 2 steps ahead, no? So fast dot next is not equal to null. What we will do, we will increment the slow pointer as well as the fast pointer. So slow will become nothing but slow dot next, and fast will become fast dot next, okay. So suppose at this position, if we will reach this position, then fast dot next is equal to null. Basically here it is null. So our previous, our you know our the our slow pointer, is giving us the midpoint of this linked list. So at last we are going to return slow as our answer for that. So this was for the midpoint function, that how we are going to find the midpoint of a linked list. Now we will move towards the reversal of the linked list. Okay, so let's quickly draw linked list here. So suppose this is going to be our linked list. Okay. 1 2 3 4 5. So we need to reverse it. So in order to solve this thing, we are going to create pointers. First one will be previous. Okay, sorry. So previous pointer we are going to create, and what it will do, it will point towards null. Okay, and we will create a fast pointer or forward pointer, we can say. Create a forward pointer here, and the current pointer will be pointing towards the head. So first what we will do, is current dot next should basically forward should equal to current dot next. Okay, so means our forward will be pointing towards this. So how I will show this is that instead of this forward writing here now, so forward will be pointing towards current dot next. So forward will be somewhere like this. Okay, now what we will do, we will break this link here. So current dot next is equal to previous. So what will happen here, it will start pointing towards null. Okay, current dot next is equal to previous. Now what we will do, we will make previous as current and current as forward. Okay, and so what will happen here, so previous will, now this position will become previous and our current will move towards this position. Okay, so now you can see that here the direction has been changed, if you can see. And now we will follow this process till what, till our current is not equal to null. And at last what we will get is our complete linked list will be reversed. Okay, so that's what we require. So with the help of this midpoint function, the midpoint function, the reversal of the linked list, reversal function, and the is palindrome function, we are going to solve this problem. So that's it for the explanation. Now we will code this problem. So in continuation of the solution part, we are going to code this problem. So as I've already discussed, that we are going to create some functions, and then with the help of those functions we are going to solve this problem. So first one is, we are going to create a function that is midpoint. Okay, so it will take head as our parameter. Okay, and then we are going to create another function that is our reversal function. So it will also take the same parameter. It is list node head. Okay, so what we are doing in order to get the midpoint, we are creating two pointers, fast one and the slow one. So we will do the same thing here, but before that we are going to write some base cases, that if head is equal to null, so is equal to null, or head dot next is equal to null. So if we have a null linked list, or our linked list has only one element, then what we are going to do, the midpoint will be the head itself. So we are going to return head. Okay, now what we will do, we will generate the two pointers, that is this node, we can name it as slow. It will initially point towards the head only, so it would be head, sorry, this node is slow is equal to head, and then again this node fast is again pointing towards the head. Okay, while fast dot next is not equal to null, and fast dot next, because it is twice faster than our slow pointer. So fast dot next is not equal to null. What we are going to do, we are going to increase our slow pointer by 1 unit, by 1 node, and the fast pointer by 2 nodes. So slow will be nothing but slow dot next, and fast will become fast dot next. Okay, fast dot next. Okay, and what we are going to return, so if if this condition satisfies, then our slow pointer will be pointing towards the middle of our linked list. So we are going to return slow. Okay, sorry, return slow. So this was for the midpoint. Now what we are going to do, we are going to write for the reversal. So the base case is going to be same, that if our head is equal to null, or head dot next is equal to null, means if our linked list has only one element, then reversal will be same. The list itself is the reversal of the original list. So the base case, we are going to write it same only. So okay, so now in order to find the reversal, we require three pointers. So list node current pointer, which will be pointing towards the head, list node previous will be pointing towards null, and list node fast or forward, we can just leave it like that. Okay, so the base cases we have written, we have made the pointers. Now while our current node is not equal to null, what we are going to do, so let's quickly move towards the board. So what we were doing here, that we were making forward to point towards the current dot next, then current dot next was made to point towards the previous, and then previous will become previous will become the current, and the current will move towards the forward. Okay, the same thing we are going to do. So forward will become current dot next. Okay, and then our current dot next will point towards the previous. Okay, previous will become current, and current will become forward. and at last previous will point towards the basically the head of the reversed linked list. So return brave. Okay, so this was for reversal of the linked list. Now what we are going to do, we are going to write our main function, that is, in order to check that whether our linked list is a palindrome or not. So base cases will be same here also. If our linked list has nothing or a single node, then it is going to be a palindrome. So we are going to copy this base case, paste it here. Okay, now we are going to call our function. So list node mid is equal to what our function name is. Let's check. So it is midpoint. So we are going to call this midpoint and we will pass our head here. Okay, now our second half, list node second half is equal to mid dot next. Okay, mid dot next. If our second half is not null, then we will break this link. Okay, so let me explain it. So for our is palindrome function, what we were doing, so we were checking that whether our second half is not null, then we were breaking this link. Okay, so that's what we will do here. Okay, so if second if sorry if second half if second half is not equal to null, what we are going to do is we will break the link, that is mid dot next is equal to null, and we will after that we will reverse our second half. Okay, so second half will become reverse. What is the name of the function? Reversal. Okay, so it will become reversal, and we will pass this mid dot next on the second half. So it will be pass second half here. Okay, so we'll move towards the board and let's see that what till now what we have achieved. So we have found out our midpoint. Now we have reversed our linked list, the second half of our linked list we have reversed. Now we need to check each of these elements. Okay, so now we will write that code here. So list node first half will be our head. Okay, so this will be pointing towards the head of our original linked list, and the second half will be pointing towards the reversal of the second half, that node. Okay, while second half is not equal to null. Okay, so in here, in both the cases, suppose if we have an even linked list, suppose if we have a linked list like 1 2 2 1, so the midpoint will be this one, because if our fast slow pointer will move one step, so the fast pointer will move two steps. Okay, and then mid dot next, sorry, second pointer, that is fast next will be null. So here this will be our midpoint. Okay, so in both the even cases as well as the odd cases, either the first half will be greater than the second half or both will be equal. Suppose if we take the case odd case here, 1 2 3 2 1, so our midpoint will be this one. Okay, so first half will be this one and the second half will be this one. So either it can be greater or equal to. So we will keep a check only on the second half, that while the second half is not equal to null, if if first half dot val is not equal to second half dot val, second is not equal to second half dot val, we are going to return false. We are going to return false. Else what we will do, else we will increment. So first half will become what? It will become first half dot next, and second second half, sorry, and the second half will become second half dot next. Okay, and after coming out from here we are going to return true. Okay, now let's quickly run this thing. So at line number 27 we are encountering some error. So current is equal to forward. Then at line number 33, at line number 33, sorry, so we need to return true here, no? Return true. Okay, and then at line number 37, at line number 37, if second half is not equal to null. Okay, so now we'll run it again. Okay, 27 46, current is equal to forward, FORW. Then at line number 46, second half is equal to second half with a small s. Line number 46, so it is going to be this one. So it is getting accepted. Now we'll submit this thing. So it is getting submitted also. So thank you.